So let's give you a question here. So we've got here a rock. Right, so three things that we want to find. So we want to find the equations of motion, we want to find the time of flight and the range of flight as well. Okay, so a few things to specify. If they don't really give you any initial values here, you can often take your origin as 0, 0. And you might want to draw a little picture too, if that kind of helps you out, like got a rock, throwing it out. Now, the important thing with this is the initial velocities here, right? So we're going to need that when we start with our initial acceleration, right? So things that we can note. We note that the initial vertical velocity is 30 meters per second, initial horizontal velocity is 15 meters per second, and you can think about the diagram which that's going to represent. It's going to look something like this. This is your velocity, and we have vertical velocity of 30 meters per second and a horizontal velocity of 15 meters per second, right? Then you remember your initial velocities can be written, if you think about your angle, theta, over here, right? With this information, you can write your x dot, your initial horizontal vertical velocity, as v cos theta, and y dot as v sine theta, right? So that's stuff that you can always use. But typically when they want to find the equations of motion and you have to derive them, you have to start with x double dot equals to 0 because there's no resistance in this situation, and y double dot is equal to, what's the initial vertical? Right, 9.8. So negative 9.8 or 9.8? This is the thing that always confuses me. Negative, yeah. Yeah? Try it, see what happens. I actually don't know. Question of whether you can use physics equations in extension 2 or extension 1 even. Very highly contested. There's a collective of people that strongly believe that you should be able to, and then there's a lot of people that believe you shouldn't. So, yeah. I mean, the safe thing is to not use it, but if you're desperate, I mean, yeah, why not? It's better than writing nothing, I think. So find for me these equations of motion. So I want to find x dot, I want to find y dot, I want to find x, and I want to find y.
So big V is like
the combined velocity? Yeah, I don't know how you want to say it.
Yeah, the combined velocity.
That's not, what's the physics term?
Just velocity. They're like the x and y.
All right, Angus, what do you got for me?
I don't know.
Okay, so we're just going to start by integrating, yeah? So we start by integrating this guy, and we're integrating in terms of t here. And this is why we kind of need initial conditions as well, because if I want to find x dot, I know that's the integral of this guy, right? Because I'm going backwards from my ladders. So I start with acceleration, then I go to velocity, yeah? So if I do that, then I am essentially going to, now, like, what is this? This is just 0, right?
Plus C.
Yes, I suppose so. I guess this is a constant, right? So C1.
So V cos C equals 0.
Yeah, I guess so. And then you know that at t equals 0, well, there's no t even here. All right, so basically, x dot is going to equal to v cos theta. So x dot equals to v cos theta, right? Y dot, though, there's a bit more interesting things going on here. So y dot will equal to the integral of y double dot dt. And then we've got negative 9.8 t plus c2. All right, your constants are going to have I think in Maths and Focus they use like d's and e's and whatever makes more sense to you. Then y dot will equal to negative 9.8 t, and what's our constant here? V sine theta? I shouldn't skip steps. At t equals to 0, y dot, c2 equals to, plus v sine theta. Cool. Sorry?
So you just leave them.
Yep. So there's our first one, there's our next one.
So screw C1. So it's,
What's up?
okay, so what happened with C1? Just
Yeah, it's a bit weird, isn't it? Guess so.
at 0 it's just 0.
Yep. I mean, at t equals 0, there's no t in that expression anyway, so it's like, whatever. So those are the velocity ones, right? We're going to use that in a moment for time of flight and stuff like that, but yeah, we'll get there in a sec. But the equations of motion, again, we have to do another step, right? And what about your initial information? Well, if they don't really specify, you're okay to assume that the particle is typically at the origin. So at x equals to 0, y is equal to 0 is the kind of idea with that, yeah. So let's integrate again. So I'm kind of running out of room, so let's go over this side. So integrating again, what are we going to get? So we'll integrate this guy. So we're going to get x is equal to this. So x is equal to, now this time there's just what's the variable? We're integrating with respect to t, right? So this is actually just going to become vt cos theta plus c3 or whatever. And then you've got your initial conditions. So at t equals to 0, x is equal to 0, that's your origin. So c3 is just going to be equal to 0. So x will equal to vt cos theta. And same thing with my vertical displacement, right? So we've got integral of y dot dt. So I'm going to integrate this expression now. Just be careful with this one. We're integrating with respect to t, so we are going to have our expression here, that with the variable already there. C4, don't blow it up. And then at t equals to 0, y equals to 0. And that looks like C4 equals 0 as well. So then our expression, y will equal to negative 9.8 t squared on 2 plus vt sine theta. Let's make sure I did everything right there. Yep, looks good. So that's the derivation for the equations of motion.